Okay, and so here's teacher example number 2. Basically the exact same concept, except we're just adding one more isotope in the mix, and we now have mass. Remember, this was the number basically rounded, so notice 203.97 is really 204 rounded. Same goes for 205.9 and 206.9 and so on. So the only difference now is that we've added this new category, which means one of two things. You're going to use this instead of the rounded number for more accuracy and precision. So here we go. Let's go ahead and switch over to our other screen so we can see how we solve this problem. So if you'll notice, I went ahead and wrote everything out that we already had and we already know. So each of our isotopes are listed for lead. Here are all of the masses that are actual and not the rounded, and then here is the percent abundance for each. Now, after that, what I'm going to do is I'm then going to go to converting to the next thing, which is our first step. First step is to convert to decimal form. So we change these numbers from percentages to decimals, and get ready, you're not going to like the first one. If I do that, I then get these numbers for all of the percentages turned into decimals. Notice this one is really, really small, and that's because the original number is really, really small. So because of that, we're going to convert this to a decimal, meaning it's going over 2 places, because percent means of 100, so move it over 2. The rest of them make sense. Those are easier seen. Make sure that you don't forget to move this one twice. It hasn't already been moved. You have to move it twice. Alright, after we convert to decimal, the next step, correct, is to multiply by mass number. Okay, so you're going to multiply that mass by the decimal number, and then you're going to use the actual mass in this case, like I said. Because remember, if it's available, your answer will be more accurate and precise. Okay, and that's really, really important, especially when we're talking about things like some that people use on a daily basis for chemists. All right, so how does this look? It's going to be ugly. We have all 4 of our numbers. Remember, we're taking this number now, the mass number and not the rounded number, multiplying that by our calculated decimals. Okay, so here's what it looks like. And if we do it out, we get each of the numbers times the decimal number, masses, and we get these huge numbers. This is probably the one example of when you would have actually preferred to have significant figures. But I went ahead and didn't worry about significant figures because it does get kind of iffy at times with this stuff. Alright, so then the next step, after you've multiplied all of these numbers out and gotten those answers, we now, yes, add up our answers. And if we add all of those up, we're going to get 207.2184928. Okay, does this number fit in between the numbers that we said originally? And it does. So because of that, we now know that this answer is an acceptable answer. You don't know if it's really the perfect answer because you assume it's going to fit into here, and it does. But because we went through so much degree of accuracy and precision, we're going to say that this is pretty much spot on. Alright, then the last thing, remember, I know it says average atomic mass, but you do not need to divide anything. All you're doing is putting it in and with a unit at the end. So if I scroll down a little further, notice all I did was add the AMU units. Adding the AMU units now tells me that I'm done. So now I'm going to switch the recording over so you can see a special someone that I'd like to say hi to you guys.